Yeah, we'll start from MCP protocol. We'll just skim the important points real quick so that you have an understanding, and then we'll do the demo real quick, and then move into the next uh, sections of this today's class. And sorry if my sound is a little bit low. I'm having a little bit of cold.
Your sound is perfectly fine, sir.
Sorry.
I say your sound is perfectly fine, sir.
Oh, thanks. Okay. So yeah. So yesterday we mainly saw how model context protocol is a new layer of protocol which standardizes how agents and its context, or for example, knowledge from different sources can be uh, integrated, and you can have a seamless interaction with different knowledge bases. And yeah, so some features of model context protocol is that it's open standard provided by Anthropic, and most of these agentic framework, whether it's Llama Index, whether it's LangChain, LangGraph, Crew AI, a lot of other Letta AI, those are the different frameworks which we use to make different agents and agentic applications, right? And all of them has implemented MCP in their framework so that we all of us agreed upon a single rule or protocol to start the session. And yeah, and now it's more like a middleware session. It's secure, traceable, where it means like even if you have like different kinds of agentic applications running on different kind of operating systems, or like different applications running on different backends, it's still a secure and traceable way of letting different your application AI agents communicate with a server. And now the biggest point is that it's LSP inspired, uh, which is to say that LSP means language server protocol, which helps our coding IDEs. For example, this is my coding IDE, one of my coding IDEs, okay? And this LSP uses something like, let me just go to Python 5, for example. Yeah, here you can show that I'm getting, there is already a language server running behind this stuff. So these are all different language servers which help me code better. Like um, it will look at the different syntax trees, semantic and syntactical uh, informations when I code, and let me know whether there is a bug or not. For example, if I'm simply declaring something like this, it will show, yeah, this is not properly defined, like, right? So, and maybe I cannot like these are the different syntaxes. It will directly show. These are not really relevant points. Okay, I'm just trying to tell you what is LSP is. So even if I put something bad in the editor, it will automatically the LSP will catch it and let me know that these statements is not the right syntax for me. And based on the working of LSP, MCP is being delivered. Uh, yeah. So enough with the presentations. I think I can really show some of tutorials. So yeah, let me just delete this line because this is an error. Yeah. Okay. So I'll start from okay. And for the people who are interested in coding real quick, you can go into my GitHub repository. I think you can get it from this is my GitHub repository, and you can go into let's check where are my repositories. I'll share you the link, okay? And if people want my help regarding how to set a repository up, you can just take it as well. So there is this repository called Pratidhvani session. I can make this repository. It's taking some time. Okay. So, okay, I'll copy this and paste it in the uh, chat window for you to understand. So, for the people who want to code along with me, you can use this repository. And how many of the people are there with laptops in front of you with Python? And yeah, you have Python. Right. Yeah, great. Okay, great. Okay. Um, so I think you're also having Git with you. How many people are interested in knowing this and doesn't have Python or Git installed in your systems who are new to programming? Okay, just give me a thumbs up so that I can just understand what's the audience like. Okay. Okay. So I think for the people who want to code with me, you can just clone this repository real quick. So you can just git clone and this repository. If you paste that in a terminal, probably it will clone the repository for you, and you will have all the data presented here. Okay, and it will have a small readme session on how to test this chatbot. Um, yeah. So for the people who want to see how the MCP works, I'll show you right now. Okay. So this is the maybe I don't know if people can see the screen,
Your screen is visible, sir.
and is it readable also?
Yes, yes.
Great. So let me just so this is the terminal that I use, and let's let's just check out what's the uh, structure of this project look like. It's a simple tutorial section, and you'll have yeah, chatbot analytics, a simple chatbot that has like certain features integrated to it, capabilities or tools integrated to it, and there's an app inside this. You can possibly it's like an analytics platform, and there is also a tutorial folder where different MCP tutorials are available. So let's get to this one by one. Okay. First of all, you have to create a virtual environment for me. Okay. And so the command to run a virtual environment is like Python. uh, you put a module like this, and then venv.vn. And uh, once you put this, like for example, you can name it anything like this. I'm just creating a virtual environment first of all uh, to load all the libraries or like download, install all the libraries are required to run this particular application. And let me just put it like this environment. So it will probably create a new folder for you where, yeah, this will create a new folder for you. Um, and we have to activate this folder to run certain things. And these are the classical methods of how we, or the older method of how we do nowadays in industry or running a new project. Sorry. Uh, okay.
Sir, you
Um.
may proceed. I think there was mistakenly one of participant microphone was on.
Sorry. Can you just repeat
I
that?
think mistakenly some participant
Okay.
microphone was on. You may proceed.
Okay. Okay. Yeah. So, virtual environment. I'm just telling it very basically. Okay. So, virtual environment lets you once you activate the virtual environment with command like source this environment bin activate. You can see that yeah, a new environment is being created here, and um, Python if you put like pip list. there is no packages installed. So if you put pip install uh, requirements, it will install all the requirements required to run this application. But this is the older approach of how we how we set things up. So I'll just want to cancel this operation and let you know what's the current way of doing it. You only have to add something called pip install UV. There's a UV tool which lets you uh, install things in a flash setting. So you can see it has resolved all the dependencies in the PyProject 2ML file. So these are the different dependencies I'm going to use or the libraries that I'm going to use. So it's basically going to be a Flask application, Python's web application. And I'm going to use LangChain as a framework, which would provide me with different functions related to create an agent or do various things related to LangChain. And LangGraph will give me access to React agent. Or I think we have already discussed about React agent, like reason and act agent. And yeah, we are also dealing with something called MCP servers. So fast MCP is a Python implementation of MCP servers in Python. So we are going to use that as well. So this is going to be a technical deep dive into how things work. First, I'll show you how how this works. Okay. So once you have set up this virtual environment, you can just run uv run app.py. Wait. This shouldn't work. Wait. So yeah, we are coming into this directory. If you just click here, you can go into this browser will open with this kind of UI. So uh, let's see what this system works, how this system works. I'm going to put like Alex, my name, and make my email. This is an like demo application of how we can work with systems. And once I start the chat, okay, it's going to ask me, okay, welcome, let's get started. What's your expectation for today? I'm going to say, I wanna learn AI and agents associated with this. So what's your background domain? I'm going to ask, yeah, I'm gonna go with tech for now. What kind of agent do AI agent do you want to build? Maybe I can go with what uh, teacher agent, for example. And it's going to be asking me like, what's the Python uh, proficiency I have? I'm gonna go with high. And, what's your experience in AI? Let's call it intermediate. I prefer hands-on. So instead of a Google sheet or something, you can also make something like this, where you can like input the data into Excel sheets or stuff. Okay. And once this is completed, suppose I am the coordinator of this organization, I can just go into something like admin, like uh, I'm just going to a different endpoint. And yeah, here I will be able to see what will be the audience inside. Okay. Mm, Just let me refresh the data. Let's just check it. It's telling me that I've exhausted my quota, but let's see. And this usually happens. Okay. Please don't worry. Let me try to get a different um, Okay, now I'm getting some response. Great. Uh, yeah. So, yeah, I'll be getting something like this. Various graphs related to what are the different people's capabilities, and the thing is that I can just go directly manually into an Excel sheet and then find the relevant informations, but I can also use an agent to get me information and run this. Okay, so let's say that okay, can you tell me that various people's uh, domains domains which interested by different people, audiences. So if I'm asking this question, to try to get some, yeah. So yeah, so I'm chatting with my data right now. So here it's getting this data from an X. So every data audience enters or like people enters, it's going into a file called Excel sheet. So let me just let me just check it. So there is a file called responses that is created automatically when we run this application. So let me just go into this application. So here I can see a lot of people writing different things. Let me try to format this. Mm, Sorry, wait, there are some auto formatting steps here in order to visualize this properly. Yeah. So when I'm hosting this in the internet or creating a web application, people can enter different data related to this, and I'll get this response in an Excel sheet. Now I can either go directly into this Excel sheet and then try to figure out which people are interested in what all concepts, or I can create a web application simply and chat with this data. That's what I'm trying to do here. So here five people are interested in tech, three people are interested in finance. Okay, and then I'm gonna ask like what are the proficiency of the people, Python proficiency of the people. Uh, yeah, so 10 people are interested in this thing, and I can ask like, can I get the personal info of people in tech tech domain? So in backend, it runs certain queries and then tries to get some data. I know I'm switching the windows really fast. So yeah, when building applications, you kind of get this approach. You can get various different types of. You can even make an agent build a chart on runtime, or like whenever you ask to build a runtime, then you can do that. So that is one application. This was just an introductory thing. I'll also show what MCP servers and how does it look like. So this was one application, and you can do this with maybe like creating a RAG application. You can try to get useful insight from very big analytics data, like dashboard data, um, on various like weather, climate, or like flood meter, or temperature variance, or like anything related to gas, pressure, anything. So yeah, I think you got the idea. Now I'm going to close this. Now reopen the tab I was in. So now I'm gonna go into tutorial session where I'll simply show what are the different uh, MCP chatbots, or like how MCP chatbot can be built using this entire process. So yeah, I'll show you the code-wise implementation of how this looks like. Okay. First and foremost, list the MCP server. So basically, we have like gone into the basic application of MCP. But how is it when you're coding this stuff? So MCP as a protocol is given by something called fast MCP. It's a Python package, and you it's like a fast API Python wrapper. So which means that you can create a simple fast MCP server with this command fast MCP, and you can name it testing demo. So this is a MCP server, and next thing you want to do is that you want to give so the whole idea of making an MCP server is that you want to expose certain capabilities for LMs to use. So here the capabilities is given by MCP tools, and write a simple Python function to add, subtract, or do some complicated mathematical thing like getting derivation of certain thing, or like integration, logarithms, any deep mathematical thing you want to do. You can like write a function here, and also you can annotate with it with a decorator called mcp.to. With this particular line, you're registering this tool with the server so that server can actually help LLM discover, yeah, there is a tool for add. And similarly, we have a function to greet. So if you give someone's name, it will say, yeah, greetings Alex with certain greet. Yeah. And this is a multiplication application function. Similarly, if you want to calculate your weight, you can give this entire function and then register with mcp.weight. So it actually names your weight in kgs and height in kgs, and it will figure out your BMI weights. Okay, BMI. I've also created a random choke generator function registered with tool. So that's how tools will be registered here. And next thing MCP can do is like it can point you towards certain resources. For example, here we are just only attaching a function to a tool. Here we are actually letting an agent discover there is a resource for it. For example, whenever you need some information related to uh, like computer science, you go into library, right? So whenever I ask a agent to get the information of my system, it can actually use resource as a methodology, and then it can like access the information. For example, if this is some way a lighter version of how RAG works. You don't store an entire schema or anything, but you store specific details which can redirect these LLMs or agents to make this work. So here I'm doing like I'm defining certain service resources here, like server information, greeting resources, hello prompt, and explain prompt. So uh, these I've configured this MCP server with all these things, and I'm trying to run this. Let me show how to run this. I just have to run like UV run. UV is the package manager I'm using. Instead of Python, you can also use Python. Python tutorial, and then I'm going to run MCP server. Okay, wait. Oh, I'm using a different virtual environment. Let me just quickly switch it back. Okay, now it should probably work. Let me see. Yeah. Now MCP server is started in my computer with the name of testing demo, and you don't have to know. It's like it is exposing all these protocols via standard input output terminal, and yeah. So this server is started. Now how, how do I like, I have to uh, connect this server with certain number of client, right? Client is usually our LLM application. So I've created a small client here, which will test each of the capabilities provided by my server. So here I'm trying to get, trying to connect with my MCP server here, right? And then I'm trying to, with my STDIO client, I'm trying to list all the tools available in that server and trying to uh, do some operation to check if all the tools are available. So let me just quickly check it. So you can close this server here and then try with just MCP client and just run it. You will run MCP client, tutorial, MCP client. This is going to be a technical deep dive, little bit of technical deep dive. So people uh, who are not like great or like starting the with Python programming, please bear with me so that we can understand it. So here, so I've run the command uv run tutorial MCP line. So this is the Python command that I've written, and it started the MCP server in the backend, and then it tried to fetch all the tools available in this server. So I can see that there's a tool available for add, greet, and multiply, calculate the BMI, and create a random job. So each of the tool is being tested. So it is testing, adding 10 plus 10, I'm getting an answer. 10 plus 20, I'm getting the answer 30. By the way, is my screen visible? Uh, can you actually read the content in it? Yeah. Okay. So it's testing the content, and yeah, 10 plus 20, it's giving a test suite. So I'm getting 30, and I'm trying to get the greet tool. I'm trying to invoke the greet tool. So I'm giving the name of the person to be Alice and the greetings to be hello. So it's generating a new greeting like hello Alice. If I give something like hello Alex, it will provide something like hello Alex. Now now the client saw that there is a tool called client BMI. Okay, so it's trying to call this client BMI tool with certain weight as 70 kilograms and height as 1.75 meter. So it is giving the result as BMI 22.9, which is a normal weight, right? And I also see a random job generator. Then I'm trying to fetch a random job. So the joke is I will tell you a UDP joke, but you might not get it. This is actually computer. How many from this team actually got this joke? This one, I'm just curious. Sorry. The joke is I would tell you a UDP joke, but you might not get it, which means that UDP packets that you that's something related to computer networks. It's that there is like two types of protocol, UDP and TCP. And for TCP, you get an assurance that the data that you are sending, the packets that you are sending is being received by the other end. But for UDP protocol, you are just streaming the data. The other person might not get it. And UDP is the protocol which you might use in streaming YouTube channel or Netflix. Simple as that. But it's a little bit nerdy, I know. Okay. So once we are done with the MCP servers and client, suppose we want to make a simple chatbot. Yeah, let's go to MCP chatbot. Okay. Let's see how this works. So yeah, so I'm gonna try to run this MCP like the project. Trying to run the first thing. UV run tutorials MCP chatbot.py. So the server, fast MCP server, which provides all the tool, is being rendered here, and then I am getting a simple chat interface. I'm putting hi, and the agent is simply saying, "Hello, how can I help you today?" So I'm saying, "What did I say?" Oh, I'm getting exhaust quota. Let me try with different. API quota is not anything. Stop sharing for a while. Once I've configured this new API, I'll let you know. Entirely same ആണോ? രണ്ടും സെയിം API ആണോ? So, hi all. So the problem is that I was like facing some resources session error. Let me just check it real quick. Yeah, I was still facing some resource accession error. Um, yeah, meanwhile, people who have like configured this, are you able to run this? Um, is anyone trying to run this along with me? If so, like someone can. No, no one's running. What was like happening? Is it API exhaustion error or like any other? You should not get API exhaustion error because you're not using it right. Can you tell me like what was the issue you're facing? Like, can you unmute?
Actually, I'm not trying.
Okay, okay, not right. Is there any computer science or people who are interested in machine learning AI department who's trying to run this? Okay, I'm hoping that there's no one. So please bear with me, like until I get the figure out the API key, we can just run this application. It was like cool demo, but let's see. Sorry for the delay. Okay, I'll continue with. One second. Is my screen visible or did it drop?
No,
Are you able to see?
Now it's visible.
Yeah. So, yeah, now it's showing a little bit of thing. So, do you remember? I'm going to ask it. Did it remember what I said? So it's telling me that a simple. So I'm trying to run this simple MCP chatbot. Although it does have the capability to connect with the MCP server that we have initialized in the start, it still does not have any memory associated with it, right? So now I'm going to give it some memory for the sake of understanding. Sorry. So we'll be running this MCP chatbot with memory for now. So the difference between MCP chatbot and MCP chatbot server is that both of them are running, trying to connect with the MCP server. Both of them do have certain capabilities. But here I'm creating an agent, but I'm also associating it with memory. The original MCP chatbot.py, which is also the same kind of thing, we are also connecting it with server MCP server. And as a client, we are trying to connect with, we are trying a model and we are making a React agent. And then we are trying to execute in a loop. But the problem is that here, no memory is involved. And in this session, memory is involved. So I'm trying to maybe show you what's the difference between that. So I'm trying UV run tutorial MCP chatbot memory. So this is the file that I'm running. So I've also included certain colors for interactive terminal. So it's connected to the MCP server, and I'm going to ask like, "Hi, my name is Alex." So agent is thinking, agent is giving, "Hello, Alex. How can I help you?" So I'm going to ask you, "Do you remember my name?" Wait, shoot. So wait. One second. Why is it not recognizing my name? I'm giving memory, right? I'm giving this memory object into as a checkpointer. So I'm getting the agent and I'm like invoking the agent, and then I'm finally getting the output. Okay, it is telling me that a particular prompt has been set so that it does not, it only greets you, and then it has abilities to add numbers, greet people, and so much more. So I'm trying to ask it to calculate my BMI. Calculate my BMI. So it is asking me, he can do that, but he needs weight in kg and height in meters. So I'm going to give it maybe 60 kg and 175 centimeter. So so it is connecting with the MCP servers and it is processing that tool request. So as you can see here, it is being connecting to the it's connected to the MCP server, and based on the input that I gave, it is calculated my BMI to be 19.6. Uh, so you can do any kind of complicated stuff with this agent. And for example, I can ask it to generate a random joke. Sorry. So it will check the server and then try to find a random joke. So this is a programming joke, by the way. Everyone might not get it. So these are the different ways by which we can integrate certain tools via MCP servers and connect with the agent. But what if you are not able to, for example, in the server file that we have written, we have only configured only 5 or 6 tools, right? Like multiply, addition, greeting, calculating BMI. What if we need more capabilities? What if I want to integrate GitHub, like the tool that we just use now? Sorry. So this is the GitHub application, and it has like a lot of code and things like that. And the funniest part is that GitHub provides an MCP server to make agents like fetch data from their files. So I've actually done that with custom servers. So the thing is that when you run the chat, made a chatbot application, and I'm also able to connect it with GitHub's public access. So I'm giving my GitHub personal access token here, which is stored in .env file. So if you have like something like this, you can give your personal access token like this, and uh, you can communicate with the data. Let me show you. UV run tutorials, MCP servers, MCP chatbot, custom. So here you will be seeing a lot of different things. So here you can see that MCP server is connected to the local server with 5 tools like greeting, adding, multiplying different things. And it is also connected to the GitHub server, and it has 26 tools. So what can you do with GitHub? I'm asking a simple question. Please don't mind this. So it is telling me that I can search, I can like create a fork a repository, like push a repository instead of like writing manual code like git clone a repository. You can like use natural language in English to do it. For example, I can I can search a user with this information. For example, there is a particular person called Mufid. Let's search for Mufid. Let me search for Mufid. This is the traditional way by which you will do it. Still loading. Wait a second. Okay, I'll just ask about myself. Okay, can you search for a person? Search for Alex V. Ajith in GitHub. Okay, I'm asking this question, and the agent is using GitHub MCP server, and just he said like, yeah, he found a user named Alex with username darker18, and it showed me a link. Okay, so I, it's asking me whether is this the person I'm looking for. Let me just check if it's just me, if it's really me. So I'm just clicking it. Yeah, it's me, right? And I have a couple of repositories in my name, and you can see the repositories here. And I'm going to ask it, can you tell me the repository he has? So agent is again communicating with the GitHub server and then trying to get, okay, what are his projects? Let me say, okay. Now it's giving a detailed instructions on what I have done in my repositories. So it's giving I've done a Pradipani session, like a repository which contains all the information, a traffic light AI agentic system, a baby cry classification system, and this is how the new this is how new technology enables us to chat with our data instead of like manually going here or like asking it to do certain stuff. It, we are able to communicate directly with servers with the power of LLMs. So I'm gonna ask it to, can you clone the repo, or like, can you, let's see if it will clone. Okay, maybe this will break. Let's see. Uh, okay, it's not able to directly communicate with GitHub API to clone this repository, but the thing is that you are able to push the repository, find a new information regarding this, or create a fork or anything. So that's how LLMs will enable us to do it. Now, coming back to let me ask what is the baby cry classification project by him? Okay, it's telling me that the baby cry classification project by me is a deep neural network machine learning approach to classify babies sound into five different categories. So that's what one of my project was. Let me see if I can show it. Yeah. So this is done very back. So it's a deep neural network machine learning approach to classify five categories of infants using a cry corpus. So that's how you communicate with different servers. And in order for you to see different MCP servers available, you can go into this. Sorry, you can go into this site called MCP Store, MCP Market. I'll copy this and share with you. So uh, we have been to github.com, and we tried. So yeah, we tried with try to connect with github.com MCP server and try to search for my information and my basic data. For that to work, you have to actually give GitHub personal access token. So that is something that looks like this. This is a code that runs in your .env file, and you'll get that information from, if you go to settings and then go to developer settings, get personal access tokens. So this is where you get a personal access token. You can generate a new token if you want. Simply name it something, and then you can copy that code and paste it here. So this code should work. So I think that's the running application of MCPs. Mm, I think I've given certain useful information regarding MCP. Uh, with should I continue? Like, can I continue? Next topic would be between A2A protocol and safety.
It's per your convenience, sir.
Yeah. Okay. Um. Okay. Then I'll just start with A2A protocol right now.
Hi, can we take a small break like, for 2 minutes? Then rejoin.
Sure, that will be perfect.
Hi. Um, am I audible?
Yes, sir, you are audible.
Sorry, 1 second. I can't hear you. Maybe. Hello. Yeah.
You're audible, sir.
Yeah. Okay. Great. Okay. Now I think we can. I'll show you a quick thing. I'll show you. Let's talk about multimodality in a practical way. I'll share you the collab. Hmm, Let me see where I've put it. Hi. So I think I shared your collab file. Um, so this gives you a basic introduction on how to use multimodal capability of LLMs to ensure that you have like a uh, good workarounds regarding your work that you are doing, even in research, even in technology, even literature or anything. So uh, you can use the multimodal capability of LLMs, and then this gives you like the hands-on introduction on how to like use those LLM models with the corresponding thing. So I think you all have access to the link that I've shared, right? You can make a copy of it. You can make a copy of it. And the thing is that you have to like go into Google AI Studio, make a API key, and then store it here. So you have to name the variable as Google API key, same as here, Google API key, and then you have to paste the studio like this. So I'll show you a quick demo how to run this. So you have to go to Google AI Studio and then get API key. Then you'll see the screen. You have to copy your API key from here. It's taking a little bit time. It's taking a little bit time. Maybe servers are busy. But I guess many of the people are now okay with creating API key, right? I think most of the people know how to create an API key. It's pretty simple. Yeah. Ajmal Samari, yeah, you can. Do you have any doubts?
Sir, mistaken.
Okay. So yeah, you can just create a new API key from here. You can select any project and then create an API key. And once that API key is there, you can copy it from here or like here, and then go to the collab and then paste it here. It's like create a Google API key and paste your API key here. Okay, and make sure that you turn the access on so that when this section of the code executes, the API key will be used in the notebook as well. So for me, I'm going to use this API key for now. Let me close this one for you and then start the application. So I run in the application. I'm importing the Google API key from this secret section. and that APK will be used in the rest of the scenarios. So, mm, yeah, it's running. Yeah, saying that it's run. Now, I'm going to create a new. So earlier there used to be different Pro and Vision models, but for now, for our use case, we're going to go with Gemini 2.5 Flash, which is like a lighter version, but it is also a multi-model. And to check that, um, to check whether a model is multi-model or not, we have to go into their website. This is Google Cloud documentation, and here you can see that it has different capabilities. Let's see what are the different capabilities it have. So here you can see that mm, it supports images, it supports documents, it supports video, it supports audio. So uh, the conventional way is only that you give only textual inputs and textual output. But here you can also give images up to 7 MB of various like formats like PNG, JPEG, WebP, and all. And you can even store these images in the cloud for a limited amount of time, so that every time you ask a question, this image will not be like uploaded each time you ask a question. Okay. And regarding documents, you have a maximum size file size capability of 50 MB, and yeah, you can even cache certain documents with the upper limit of 7 MB, which means that you don't have to like give it 7 MB every time. It also has the capability to process video and audio as well. You can see the supported MIME types here. So for example, if you want to uh, transcribe a video or movie or like a film trailer or like a small introduction to machine learning YouTube, you can download the video and convert it into a format into this format and feed it into Google Generative AI and ask it a question so that it will give you a summary of the entire conversation or something. There are various other use cases for audio transcription. For example, if you're making a application to summarize the meetings, you want to get the audio from that video file and then maybe use that to get the transcription of the what different speakers are doing. And one of the greater capability of these agentic models are they are able to identify various sound by various speakers. So it can distinguish between, suppose me and maybe Harida is talking a conversation. These LM able agents are able to identify, yeah, there are two different speakers and each of the speaker is maintaining this kind of conversations. So that are the various things. And this is basically the we call model card of a model. It has a different capability. It has the all the information related to that particular model. And let's go back to this session. And here we are going to use Gemini 2.5 Flash. We are executing this command. And here I'm asking a simple text only generation, a research based brainstorming. So I'm going to ask it a question like, suggest three novel disciplinary research topics focusing on artificial intelligence and environment sustainability. For each, briefly explain its own potential impact. So uh, once this prompt is being passed into this Gemini Pro model, it will give you text out model. So you might imagine why it is outputting the response like this in a particular code-like manner. It's not particularly readable, right? That's because this is giving me input output into a markdown format. For example, if I copy this one, I'll copy this entire thing. This is like code specific thing. So you can even ask LLM agents to give it in a particular style, like how research briefly explain it potential made in the style of how Shakespeare writes. Shakespeare writes it. So let's see how the input looks like. Oh, exceeded errors. Again, I have to like Go back to mode. Take this API key in the Gemini. I have to paste this, and once that's done, I have to go again and import the key. I have to initialize the model with that API key, and then try to run this agent once again. So now it's running. Oh, too many requests still. Let me try this once again. Okay, it is exceeded some. Uh, so people who are doing collab, are you able to see this as well? Or are you facing the uh, issues with quota? Let me just quickly- API ഉണ്ട്. Yeah, great. Hi. So Indu's telling she got output, and can you just present the screen? Can you like, if it's possible? Hello, am I audible?
Yes, I think she shared the screen. Can you see in the screen, sir?
Yeah. So here, I think Indu has executed that cell, and probably she has got the output. Can you okay? Can you run the second cell right now? Uh, Image based generation. Next. Yeah, here she has executed that as well. So here I'm giving a image URL. So can you just go to that particular link?
you can press Control and enter, Control and click. Otherwise, it might be loading in the same tab. Maybe it has opened in the next tab. Check it. Oh, by the way, I think she's sharing only the collab tab, so other tabs will not see. So the image would be basically what is shown downwards. So uh, that's a sample resource graph, and it's a interpolation between car price and fuel efficiency. And if we are getting some data like this, we can ask the agent to derive some inference based on this information. So the code snippet above and the prompt like image description prompt tells like describe the key features and trends shown in this scientific graph. So we are executing the Gemini vision model here, and we are getting some output. Can you scroll down a little bit? Great. So here it's giving some information regarding how the trend is going. With there's no clear linear correlation, and uh, car price around 25,000. Yeah, it's giving some summary regarding this information. So, in your perspective, if you're working on some project and stuff, you can, if you do not understand what it actually means, you can use the agents to like understand every information that you have, whether it be image, whether it be text, whether it be audio, video, any kind of document, PDF files, text files, or anything. You can give this to LLM if it supports multimodality. Okay, and then derive information, and based on all those information you can like generate better reports, better inference, better findings and stuff. So can you go down here? What we are essentially trying to do is that um, we look at the second line here. It's saying that Gemini vision model to generate content, it's we are giving not only a prompt but also an image associated with it. So based on an image we are able to prompt it version. So the provided graph can give you any other like it is showing that it's a graph with x-axis and y-axis plotted, and the specific has no direct or inherent implication for a study on ecological population dynamics. But if you can maybe uh, you can like change the prompts accordingly, you can change the image accordingly and try on your own. Okay, and that's the basic part of it. So now can you stop sharing? Like I'll just yes. Thank you, Indu, so much. Thank you so much for your contribution. Thank you so much. Yeah, I'll uh, put this reference as well. Yeah, I'm gonna share my screen right now. Okay. Now I'm going to what ATO protocol looks like. Uh, so since we have multimodality, I'm going to a technical deep dive into ATO protocol. I'll just keep it really short so that I'm not going too much deep into what ATO protocol is. So already we have already seen what MCP protocol is. It's a mechanism by which LLM agent can has a unified rule or unified standard to communicate with different resources in a server. Let it be a database, a relational database, let it be GitHub, let it be YouTube, let it be any other application that's available. If those servers have an MCP server, we can connect to that servers and get the relevant details. Uh, in what is different in native is that consider we are doing a multi-agentic system where an agent instead of let's say uh, let me just really take a different thing. Skeleton. So earlier we used to have an agent like this, right? This is an agent, and we are a human being. Human. And we will be asking question. We will be asking question to agent, and this agent will look at another server. Let's call it server. So all of you might be all of you are like good with cinemas. Like let's call it Book My Show server, and they will be exposing an MCP server to their server. So these servers will help our agent communicate betterly, but in better sense to these Book My Show with just natural languages, and probably it will get the response back to agent, and the agent can communicate back to you. And that's how a single agentic system works. But what if they are not giving an MCP server, but we need multiple approaches? Like instead of this, they might actually provide you different services, and specializing on different services, you might need different agents. So they will have an agent here. This is server agent one, okay? Server agent. I'm sorry, I'm bad at drawing. This is server agent two. And in a multi-agentic system, many of the agents needs to communicate with each other. And how do you ensure that the agents communicate with each other in a standard way? For example, this agent might be built using LangGraph, and this agent might be running with Letta AI, and the other agent might be running with some custom logic, custom agentic frameworks. And how do you ensure that different agents communicate with each other in a very standardized way? In order for that to be enabled, Google wrote something called A2A protocol. That is agent to agent protocol. So here, an agent can goes to an A2A protocol, and then this A2A protocol will enable different agents to have a unified platform. And it will transcribe what the different approaches are, and this A2A server will get the information from different agents. So that's how this kind of information flow actually happens. I think you understand that. Like even if there are like multiple agentic systems, they can communicate with this data with they can communicate different agents together with A2A protocols. So that's the basic difference between a MCP server and an A2A protocol, A2A server, right? And that's the difference between. Let me just go into the slide really quick. So A2A protocol is a communication protocol between different agents, and it works with HTTP protocol as a layer to be communicated with each other. It is on top of HTTP protocol. A2A protocol works. So the main function side, it delegates different tasks. The main agent will try to talk to sub agents that this task is for you, and I need this task to be completed. It can also store different. It can negotiate with agents as well. For example, if one agent say that I'm already overloaded with some work, it using A2A protocol, the main supervisor agent can like streamline the workflow into other agents as well. So negotiation also happens. And suppose the main agent does not have a particular information that sub-agents might have. So sub-agents can actually store, give a part of its memory to the main agent to function, to make the entire agentic orchestration work in a unified manner. So that is state synchronization. Memory can be stayed across different agents via A2A protocol. And of course, how do you ensure that like there are like 500 different agents, sub-agents? Thanks. Thank you. There are like 500 different sub-agents, and there is a main agent. What, like, for example, if you have a teacher and there are like 500 different students, if teacher does not know the different capabilities of all the 500 students, it will be very difficult for her to manage those 500 people, right? So in a way, A2A protocol also exposes the different capabilities that each agent have. That's the difference between. That's the one of the key features of A2A protocol. Now, this is a little bit technical deep dive. I'm not going to go into a very whatever we have discussed here. It's discussing in a more technical way. So, in a very simple manner, it gives you an identity layer to the information, which means that uh, every agent that connects to this information to this protocol will have a self identity. What are its capability? What is the scope of privileges? What are things that it can access? So that's the identity layer. Capability layer is that every agent that joins that server will have an access about what are its capabilities. So it's a dynamic look. Even if during a runtime, some of the capabilities changes, API protocol will enable you to understand, discover what are the like growth of capability and the reduction in capability, even while the server is up. And then there's a standard message protocol. So everything that goes into this protocol goes into a particular format like this, right? And there's a task lifecycle. For every task that the top agent will delegate to the smaller agents, it will enable those smaller agents to have a time down of how much work it has done, whether it's getting overloaded, whether it's taking too much time. So just like how humans interact in the real world, we have created a standard approach on how different LLMs or agentic agents talk to each other in a gigantic orchestration level. So in the agent identity level, every agent will have its own unique ID, a public key, capability, and schema. Public key, you might need a public key to make sure that you have an access to the right agent. For example, mm, what? Uh, for example, if you are in an organization, if you are, let's consider everyone in an organization to be an agent, right? And as a developer or as a person who is in sales, you don't technically require every information that a person in finance department has, right? So in that level, only if the finance department share its access to you, like as a sales team, then only you can communicate with the right agent. Otherwise, everyone will talk with every other agent, and if some agent is like uh, publishing some sensitive information, every other person can take it. So that's not the right way. So this is a standard JSON approach on how the data is being defined. So agent will have agent ID, capabilities, and its input schema, its output schema. So this protocol will enable every other agent to communicate with each other, right? So yeah, and, um, this is what you said. Even if different agents have different capabilities, it can broadcast in the protocol on the server that I have the capability to look into the finance document. So if any other agents who's looking to communicate with me can actually contact me. That's how the capability discovery mechanism works in an ATO protocol. Um, there are other different payloads, but we may not focus into that, right? It's different. Now task life cycle, because you when an agent actually takes up a work, an agent A will propose that task into another agent. Agent B will negotiate. It can accept, reject, or counter propose with lower parameters. Uh, just in the scope of agent B, so that agent B will not be overburdened. It has the capability to negotiate back to agent A that I can do only this much of work. You cannot give me any kind of work. I will do only this much of work. And these are all configurable, by the way. And also the best part is that every agent in the system is autonomous. You don't have to technically code how they are going to behave. They will be behaving according to the prompt that you are setting. That's the policy with which they are going to work. And yeah, agent B will execute it. It will complete a response and will go back to agent A. And agent A's task is to validate whether the objective of the task is met or not. Okay, and the task shall not go in an endless life cycle. So if agent B, even after many tries, is not able to complete it, agent A should say that, yeah, agent B is incapable of doing that, so we might need to look for other agents, right? And memory synchronization, which means that uh, agents can also share their memory, not the information that they have, but also the entire memory they have can be shared across different agents. Uh, Here you can see that one of the agent is running using LangGraph, another using AutoGen, another using AutoGen. So you can communicate different frameworks with the same protocol. That's how it is. Now they have built certain authentication and authorization level so that you can only contact with the right kind of finance team, right kind of agents. For example, if you want to get your certificates from the principal of the university, you have to ensure that you are talking to the right person. The principal should be the one who is legitimate, right? So you have to gain a level of trust to ensure that the agent, the principal agent you're talking with, is the legitimate one, and you're not giving any confidential data to the person. And sometimes what happens in the group is that you will what uh, sometimes another person will post that like a principal of university and tries to get as much information, sensitive information from you, and then later use that information to hack you in certain ways. So that's how trust and verification layer is ensured in this protocol. I also want to, um, uh, so we have spoken about the safety practices here, and let me just go back and just share a very few informations about what are the different technical safety practices that has to be ensured into an agentic system. This will cover basically the things that you know, basically the things that you see around in your day-to-day life, and yeah, we'll try to make it concise as possible. So let's look at some of the problems. So almost every organization that you see in today's world has adopted some form of agentic AI system. Which the problem with the good part of agentic system is that it's autonomous. That you don't it is working on its own. But the bad thing about agentic AI system is it's autonomous also, because you don't have any control about what is going to happen. So you have to engineer the agentic AI system in such a way that no unauthorized person will have access to your information. But also you have set clear boundaries on how this should work, right? And yeah, so we'll go to the next part. Uh, the problem with agentic system is it's non-deterministic. So it's non-deterministic because it's decision making based on the input that you give. Also, I think we have discovered something called seed or like hallucination. The LLM generates different responses each time. So it's a bit of non-deterministic value. It can give you any some sort of value. It's not like the deterministic program that we run in daily classical algorithms, right? Uh, like yeah, it can give you different inputs. So based on complicated how complex the workflow goes, you kind of anticipate that many ways it can go failure. Uh, and then there are different layers of interaction, like external APIs, internal APIs. There is persistent memories. So each of these core components can be hacked separately, which means that uh, someone can inject a fake memory into your application, and the LLM can go nuts. And if the external API is some sort of hijacked or some sort of compromised in security level, then also it's going to be affected. And amplification in terms of basically every error that LLM can make errors on one layer. And if 500 agents are working together, if one agent make a mistake, one agent makes a problem with data poisoning, like they are like making false data or incorrect data, another agent will get the inaccurate data and they will process accordingly, and the other agent, the rest of the agents will, the fault in one agent will
Sorry,
cascade. Sorry, am I not pressing me?
presentation is okay. Your voice was cutting before. I think it's
Okay,
okay now.
okay, great. So what I was explaining is that, yeah, if one agent makes a mistake, the rest of the agents will only get the input as a mistake, and they will also make a mistake. So while propagating the action chain, the mistakes will accumulate like a avalanche. Now, what are the technical risks associated with agentic AI? You kind of get prompt injection. There will be brilliant hackers who can like maliciously add some prompt code to like expose some sensitive data about yours, and maybe relax certain like some some things you've set like clear instruction. They can like manipulate that clear instruction and make sure that make that agent do things according to their will. And then there's something called identity spoofing. Instead of if the user's legitimacy can be compromised, they can get access to your information. What if they are compromising your tools? If the tools are not written properly, the capabilities can be used by the hackers in a way that they can like make your agent run some system calls in your computer which are very bad. So they can make maybe open a backdoor into your company, reverse proxy, anything they can do. So tool execution is something other thing, and cascading failures that we have already the error propagates across. And how do you like solve this? Like you need human intervention on every layer. You have to like test it or you have to test it in day in day out. You have to make sure that LM or this agentic orchestration is working in an isolated environment. And uh, what I mean by isolated environment is that it works, it should work uh, independent of your operating system, and it shouldn't be able to access your operating system in a fundamental level. Uh, then of course your LLM agent will be compromised. Uh, Another real world case like NVIDIA's Q research agent. It is able to find some like very interesting things about its own research and make new inferences, and they have actually accelerated their growth by a great percentage. So you can you can use these practices for technically ensuring that agentic system works in a very safe, secure, and private manner. Um, you can like make a monitor of real-time monitoring how LLM agent is, how much request is coming, how much CPU is being utilized. If there is any other unauthorized access, all things should be monitored. Every entity should be authorized and should be made legitimate once we are working in a very organization level. Now, we have talked that every element or layer of agentic system is vulnerable. So you should make sure that every agent is having their own guardrail mechanism. If it's prompt, you should make guardrail system such that the prompt should be immutable, which means that prompt cannot be changed once that application is deployed, right? And prompt should be have clear instruction on what are the boundaries of LLM agent should go. And we should also abide by the international compliances set by different authorities. So yeah, prompt engineering safety, clear ambiguous instructions. We should like anticipate what are the attacks that are going to come, and then give clear instruction to the LLMs how they're going to solve it. Yeah, probably that's prompt engineering safety part. Yeah, we should give agents real life cases. Okay, how attacks can come, and what are the only capabilities that you have. You cannot go out of these capabilities. For example, if you are building book my show agent, right? Book my show agent should only uh, like give you information regarding movie tickets or shows. It should not give you something related to your finance data, or something related to maybe cricket or anything like that, right? So yeah, so we should have a clear understanding about that. Then everyone who's building an agentic system should have an ethical conscience on their own. Um, you have to like respect other people's uh, privacy also. There are tools like Langspit here and that have a native observability solution, which means that you can see every action that an agent is doing, like tool calls, like input from the user, output to the user, the document it has read, the timestamp of the document that it has read, the memory that it has used. So everything associated with agent can be traced with Langspit, Langfuse, and other agents as well. And yeah, you should have a clear human factor oversight on every other governance, every other factor about LLM. That's what we discussed so far. Yeah, I think that's almost everything in the entire section. So I think we have completed practical session about MCP. I mean, I've given you code related to how to run an MCP code. We can test it with Google API key. We have just worked with MCP 8 multimodality. Then I'll also show you some of the what about 8-way. There's a site called 8waprotocol.org. This website gives you how we can use. It gives you a lot of tutorials and samples, Python samples on how to run uh, run a basic 8-way client. Probably you need a Google Cloud access or something, but probably yeah, this will do. You can go to this site and it will have all the tutorial sessions regarding YouTube protocols. It's not currently very popular. Very popular since a lot of companies are not using it because yeah, only if you're a good engineer or good organization with capabilities to invest into AI, agentic AI, you're going to use it unless mostly MCP servers can do. So you can check this out also. You can copy the link and give you into your chat. Sure. Yeah, that would probably be it. Thank you everyone for joining in. I hope I've given you some information regarding how to code AI. Thank you for thank you coordinators for welcoming and yeah, thank you for all the support.